In this video, we're going to learn about something called contingency tables. Before I get into the actual topics here called marginal and conditional distributions, I want to point out the example we have. So this is what we're looking at when we're talking about a contingency table. It's just a table of data values where you are breaking up individuals in your sample into different categories based on the values of, it looks like, two different qualitative variables here. So this data is made up data, but the idea is whether someone quit smoking or did not quit smoking based on different treatments. The treatments, in group one was everyone got the same treatment. In group two, everyone got a different treatment as the first group. And same thing, group three, maybe one of them is a control group. Regardless, when you have a table like this where you're breaking up people based on two different qualitative variables, this is our contingency table. Now you'll see that in each one of these we have frequencies here. Sometimes we might want to have relative frequencies, but we have to be careful there because we have to decide what we're going to have to divide by in order to do that. The first thing we're going to do is we're going to see how many people are total in each row and each column. So if I go down in the columns here first, 52 and 13 is 65. So that means there were a total of 65 people in group 1. 54 plus 9 is 63 people in group 2. And 51 plus 4 is 55 in group 3. Now, you might wonder, well, wait a second, if we're trying to test different treatments in whether someone's going to quit smoking, wouldn't we want to break up the groups evenly so they have all the same number? And that would be a good idea, but sometimes that's not feasible. For example, if we are randomly selecting people depending to put into a different treatment group, we may not always select equal numbers in each of these groups. It could be that maybe we did start out with equal numbers and someone joined the study late, or it could be for some reason someone had to leave the study and we removed them. So we don't really know. We can't really expect them to all to be equal. So we just have to add down, find out what that is. Then if I want to find out the totals on the rows here, 52 plus 54 plus 51, that looks like it's 157. Then we go down to 13 plus 9 plus 4 is 26. So we have our row totals and our column totals. Now, let's see what happens if I were to add down. So if I did the 157 plus 26, I get 183. And if I were to add across the side, 65 plus 63 plus 55, I also get 183. And you better get the same answer, 183, whether you add down or add left to right here, because this is the total sample size. And it should be the same no matter which way you are comparing it. Now, what we're doing here, we're adding these up. These are telling us our marginal distributions. So the idea is when you have the full contingency table, you have all the data broken down by both variables at the same time. If you want to look at just one variable at once, so like over here, we say 157 did not quit, and 26 did quit. I've taken my details, and I've lost some of them. I don't know who was in group 1, group 2, or group 3 anymore. And this is just a result that just tells me about the variable quit or did not quit. These tell us marginal distributions. And same thing over here. This tells us how many people were in group 1, group 2, group 3. But we have no idea who quit or did not quit. So it's a marginal distribution. It's just getting some of the information based on the table. Now, occasionally we want it in terms of frequency here, and then we would just leave it like that. And other times we might want it, as I said earlier, in terms of relative frequency. So let me first copy down my original contingency table here. 13, 9, 4. And then we knew on the side here that there was 157 total, but let's say that's out of the sample size 183. So 157 divided by 183, and that means there was 85.7% or 0.857. Actually, sorry, if I round it better, it's 0.858 here. Or again, as I said, 85.8%. And then if I did the same thing for the second one, 26 out of 183. Put that in my calculator. And then I get 0.142, which is 14.2%. So this is giving me my marginal distribution, but in terms of relative frequency instead of frequency. And there are definitely times when we want that. It's still the same information. You could still go back. If I give you relative frequency, you could then, instead of dividing by 183, you could multiply by 183 to get back the frequencies, or you could just add up again. So whether it's frequency or relative frequency, it's still the same information. It's just how you're choosing to present it. If I go ahead and divide on the bottom here and say do 65 over 183, I get 0.355 or 35.5%. And then this one would be 63 over 183. Put that in my calculator. And that gives me 0.344. And lastly, if I put 55 out of 183, and that gets me my 0.301. So these are our marginal distributions, both in terms of frequency as well as relative frequency. And now we have that terminology down. So if I were to ask you, here's a contingency table, determine the marginal distributions for both variables in terms of relative frequency, this is exactly what I'd be asking you to do. The second thing we might do in terms of a contingency table is look at the conditional distributions. And these are not the same as the marginal ones. However, we are going to use the calculation that we did up here with our frequencies for a marginal distribution. Now what I'm going to do is I'm going to say is that, how about within group one, what percentage quit and what percentage did not quit? So if I asked you, within group one, what percentage quit? So I would take my data here, and I'll go ahead and copy the table down once again. We had 52, and then 54, and 51, and 13, and 9, and 4. Now what I'm going to do is I'm going to say, okay, within group 1, we know 52 did not quit and 13 did quit, and we know that there's a total of 65 in group 1. So then what's the percentage within group 1 that did this? I could divide those by the number of people in group 1. And if I did 52 divided by 65, I would get 0.8. So that means 80% did not quit. And then 13 over 65, we better get 20%. So within group 1, 20% quit. I want to point out over here, within the whole sample, only 14% quit. So looking at these two different ways of calculating these percentages, we see that the group 1 success rate for getting people to quit was better than the overall sample success rate here. So we can use these and we can compare these two rates and say, oh, well, maybe group 1 was more effective on average. Now this is very important because you need to know exactly which numbers you're dividing to get the right answer. And you have to understand what you're talking about in order to do this. Because like I said, if I ask you what percentage quit, and that's all I say, the answer is 14.2%. If I say what percentage of people in group 1 quit, then it's 20%. What if I say, what percentage of people are in group 1? Well, what percentage of people are in group 1? That would be 35.5%. However, if I said, what percentage who quit are in group 1? So we have to be careful here. What numbers are we going to divide? So we take a look at the people who quit in group 1. There are 13 of them. And we have to divide by something here. So we need to see which group of people are we talking about. We are talking about the people who quit. So how many total people quit in this study? It is 26. So that means that 50% of the people who quit came from group 1. So you see, you have to be very careful when reading these problems to say which group of people are you talking about. That's what you are dividing by. And then we want to see what property they have. In this case, are in group 1. That's the number that's going to go on top. So these can be pretty tricky. And in my opinion, the only way to get good at them is just to practice them. So, when you do your homework problems or just come up with other contingency tables, make up some numbers here, start asking random questions, and see if you understand which numbers to divide by to get the answer you're looking for.